Hello, everyone. My name is Ted Dziekanowski, and on behalf of 327 Solution Training and Parava Cyber Consulting, I'm very pleased to be speaking to you today about achieving NIST Special Publication 800-171 compliance using the Cybersecurity Framework profile for manufacturing. As you can see from this list of NIST Special Publication 800-171A assessment objects, the number of plans that you actually need to create to be assessed as being compliant with 800-171A is rather significant. You need business continuity plans, you need continuity of operation plans, crisis communication, incident response, occupant emergency plans, physical environmental protection plans, security plans, and most importantly, a system security plan. If you look at the numerous objects that are assessed in NIST Special Publication 800-171A, the number of policies and procedures that you also need to create is rather significant. You need policies on, say, as an example, access control, password policies, personnel security, system and information integrity, system and service acquisition, mobile code implementation. So, what exactly is the problem? Well, the nature of the problem is essentially one of NIST Special Publication 800-171 itself. The primary focus of NIST Special Publication 800-171 is on federal contract information and controlled unclassified information. What NIST Special Publication 800-171 doesn't give you is a methodology for control selection and implementation. We have other NIST standards, however, that do provide you with a more complete compliance solution. And the nature of that compliance solution is really the whole concept of a cybersecurity framework profile. Cybersecurity framework profile has lots of benefits associated with it, including being able to be adapted to numerous potential other reporting requirements like environmental, societal, and governance reports that are being adopted by many regulators. And not only that, not only regulators, but your customers as well, your customers and your stakeholders. So, what are we going to be talking about? Well, we're going to give you the logic behind the Cybersecurity Framework Manufacturing Profile version 1.1. And we're going to talk about the differences in control requirements between the Cybersecurity Framework Profile and NIST Special Publication 800-171. If you'd like more information about what is being presented today, I would recommend that you take a look at the Defense Industrial Base Guide to Implementing the Cybersecurity Framework, the Cybersecurity Framework Manufacturing Profile version 1.1, the Framework for Improving Critical Infrastructure Cybersecurity version 1.1, NIST Handbook 162, which is about cybersecurity self-assessment, for assessing NIST Special Publication 800-171 security requirements in response to DFARS cybersecurity requirements. Of course, you should also be using and taking a look at NIST Special Publication 800-171 and the assessment guide for NIST Special Publication 800-171, which is NIST Special Publication 800-171A. So, what is the Cybersecurity Framework Manufacturing Profile? And more importantly, why should you use it? Well, first, if you do a simple search about cybersecurity framework profiles, you're going to find that they are widely adapted across multiple areas of critical infrastructure. As an example, the Coast Guard has several cybersecurity framework profiles for passenger ships. The advantage of using the cybersecurity framework profile becomes immediately visible to you, because what the cybersecurity framework profile is going to do is going to add governance and risk management to the process of implementation of the necessary controls within that particular framework. We don't quite know what the future of 800-171 is, whether it might be replaced by something a little bit more rigorous like NIST Special Publication 800-53R5, but it is somewhat more future proof. And in fact, you could add as many controls as you wanted to add. The baseline controls that are in 800-171 are just those. They're just baseline controls. What I can certainly envision at some point in the future is that the cybersecurity framework profiles, especially the one for manufacturing, might be very helpful in your demonstrating compliance with regulatory requirements like ESG, that is environmental, societal, and governance controls, along with the various privacy laws that are being implemented across the United States and, for that matter, the globe. As referenced within the framework guide itself, this particular framework was developed based on input from multiple critical industry sectors. It includes a collection of related cybersecurity standards and industry best practices. So from within this framework, you're going to have guidance on risk management principles and best practices. There is a common language and taxonomy that you can use to address and manage cybersecurity risk. It gives you a structure for organizations to understand and apply cybersecurity risk management. And perhaps most importantly, it'll identify effective standards, guidelines, and practices to manage cybersecurity risk in a very cost-effective manner, which we are going to get into. Now, the one telling piece of the documentation is this statement. For those DIB organizations, those defense industrial base organizations charged with implementing the security requirements outlined in NIST Special Publication 800-171, understanding the linkage between implementing the framework and accomplishing NIST Special Publication 800-171 security requirements is the primary focus. Some additional benefits. You get to assess and describe your current and potentially targeted cybersecurity posture. Now, you don't have to worry about a pass-fail. You're going to identify gaps that you might have in current programs and processes. Because this is a risk-based process, you're able to identify and prioritize opportunities for improvement using a continuous, repeatable process that is recognized across the industry. You can assess your progress towards reaching your cybersecurity target posture. And also something that is exceptionally important, you're going to be able to communicate your cybersecurity posture in a common, consistent language to both your internal and external stakeholders, who may very well include your customers, regulators, investors, and policymakers. The cybersecurity framework has a structure associated with it. There are three components. We have a core, we have implementation tiers, and profiles. This is going to help you identify your cybersecurity practices and give you a context for a cybersecurity approach. The cybersecurity framework core gives you a set of activities to achieve specific cybersecurity outcomes. The core is comprised of four elements: functions, categories, subcategories, and informative references. The first one of these cybersecurity framework function areas is identify. So the purpose of the identify function area is to help you develop an organizational understanding to help you manage the cybersecurity risk to systems, assets, data, and capabilities. The categories within the function of identify include asset management, business environment, governance, risk assessment, and a risk management strategy. For the protect framework function area, the purpose of the protect framework function area is to develop and implement an appropriate set of safeguards to ensure the delivery of critical infrastructure services. Some of the categories within this function include access control, awareness and training, data security, information protection processes and procedures, maintenance, and protective technology. The next framework function area is that of detect, where you are going to be developing and implementing the appropriate activities to identify the occurrence of a given cybersecurity event. So some of the outcome categories within the function include anomalies and events, security continuous monitoring, and detection processes. The respond function area is about developing and implementing the appropriate activities to take action regarding a detected cybersecurity event, especially appropriate in these days of ransomware. The examples of some of the outcome categories within this function are going to include response planning, something that's going to be very important these days, communication, analysis and mitigation, and finally, improvements. The recover framework function area is about implementing the appropriate activities to maintain plans for resilience and to restore any capabilities or services that might have been impaired due to a cybersecurity event. Categories within this function include recovery planning, improvements, and communications. So looking at the framework core structure, on the far left, you see functions. In this particular case, you're organizing basic cybersecurity activities at their highest level and aligning them with existing methodologies for incident management. The categories are going to subdivide the functions into groups of particular cybersecurity activities or programmatic needs, like asset management. The subcategories will divide further into specific outcomes of technical and management activities expected as a result. And here we are listing the very specific activities that you are going to be conducting. Now, with the informative references, there are a couple of important things to note. First, you should notice the different control frameworks that are incorporated into the informative references. The advantage of this particular approach is it doesn't really matter where you are or what you are using as a framework. The point is the controls can be mapped within the cybersecurity framework profile to correspond to whatever organization or need you have to satisfy. The cybersecurity framework is as much about progress as perfection. We're looking at different implementation tiers within the cybersecurity framework profile. Now, if you're a business, you have a couple of different choices. If you are aware that a company that you choose to do business with is at a particular tier, well, you can accept the risk. On the other hand, if there is a requirement of your being at a certain tier, well, then this is something you can progress towards and communicate towards the individuals and companies that you're doing business with. So at tier 1, the organization's cybersecurity risk management practices are not formalized. Risk is managed in an ad hoc and sometimes reactive manner. You have limited awareness of cybersecurity risk at the organization level, and an organization-wide approach to managing cybersecurity risk has not been established. At tier 2, you are risk informed. You have risk management practices approved by management, but may not have been established as organizational-wide policy. There is at least an awareness of cybersecurity risk at the organization level, but an organization-wide approach to managing cybersecurity risk has not been established. At tier 3, it is repeatable. The organization risk management practices are formally improved and expressed as policy. There is an organizational-wide approach towards managing cybersecurity risk. And finally, at the highest tier, tier 4, the adaptive tier, The organization adapts its cybersecurity practices based on lessons learned, and it's going to use predictive indicators derived from previous and current cybersecurity activities. You have an organizational-wide approach towards managing cybersecurity risk that is going to use risk-informed policies, processes, procedures to address potential cybersecurity events. We're next going to talk about the Cybersecurity Framework manufacturing profile. So the manufacturing profile is geared towards those members of the defense industrial base who service and sell products to the Defense Department. This particular profile gives you as a manufacturer a method to identify opportunities for improving the current cybersecurity posture of a given manufacturing system. It gives you the opportunity to evaluate your ability to operate the control environment at an acceptable risk level. It will also give you a standardized approach to preparing a cybersecurity plan for ongoing assurance of the manufacturing system's security. Again, really critical in these days of supply chain risk management. Some other aspects and viewpoints of the Cybersecurity Framework manufacturing profile. You have 98 distinct security objectives within the primary functional areas. This next part is important. You can develop a manufacturer-specific or sector-specific profile at defined risk levels of either low, moderate, or high. So if the only activity that you're engaged in is, say, cutting grass or painting a building, well, your risk level is going to be low. On the other hand, if you're designing components for the F-35, the risk level associated with your manufacturing of those components might be considered high. One final thought about this, the manufacturing profile will give you a prioritization of security activities. And these security activities are going to be aligned towards very specific business and mission goals. You're going to get relevant and actionable security practices that are going to be implemented to support key business mission goals. And these are infinitely expandable, not limited by anything here. There are a couple of different perspectives. You're going to be looking at a current profile, which is the outcomes from the framework core that you are currently achieving. You can establish a target profile based on contract requirements that will focus on a desired security outcome that can be used as a selling point and as an opportunity to not only improve the current cybersecurity posture of a given manufacturing system, but to also present yourself as an organization heavily focused on cybersecurity in the manufacture of products and services. Manufacturing profile is going to give you a prioritization of security activities to meet a specific business or mission goal. You will have relevant and actionable security practices that can be implemented to support whatever key business or mission goals are subsequently identified. We have, as an example, a target profile use case. So you can be a manufacturer that may utilize the target profile to express cybersecurity risk management requirements to an external service provider, such as a cloud provider. You could be a manufacturer who wishes to express a system cybersecurity state through a current profile to report results relative to the target profile or to compare with acquisition requirements. Again, it's about equal buyers and sellers in a marketplace. A critical infrastructure owner or operator, having identified an external partner upon whom that infrastructure depends, can conceivably use the target profile to convey what are your required cybersecurity outcomes. If you are a critical infrastructure sector, you can establish a baseline that can be used along with its constituents as a sector-specific starting point from which to build tailored target profiles. So based on the nature of the business that you're in, if you were in chemicals, if you are in energy, you can build these cybersecurity framework profiles to match your requirements and that of your customers. These are the cybersecurity framework functions and categories. So the function unique identifiers will include identify, protect, detect, respond, and recover. There will be within these categories unique identifiers for the different categories. And what we're going to do as we go through this is we are going to select very specific controls and compare and contrast what the cybersecurity framework profile would have you do versus what 800 and 171 would do by yourself. Now, in the cybersecurity framework profile for manufacturing, these mission and business objectives are quite interesting for different reasons. So first, if you're familiar with the concept of environmental, societal, and governance controls, this is something that is becoming exceptionally popular. There is a potential for future FS Securities and Exchange Services requirements. And the first one, of course, is to maintain environmental safety. So you've got the environmental stuff covered. Here, this particular manufacturing mission objective is to manage the cybersecurity risks that could adversely affect the environment, including both accidental and deliberate damage. Cybersecurity risk on the manufacturing system could potentially affect environmental safety. So what the controls are going to do is help your personnel understand the cybersecurity and environmental safety interdependencies. Maintaining human safety. If you have a cybersecurity risk, that could potentially affect human safety as well. Cybersecurity risk on the manufacturing system could potentially adversely affect human safety. If you have an industrial control system, if somebody decides to compromise that industrial control system and bypass the safety controls, human beings can be hurt. Maintain production goals. Manage the cybersecurity risk that can adversely affect production goals. The cybersecurity risk of the manufacturing system could potentially include asset damage, which could adversely affect production goals. So if my systems were offline, in the case of the Colonial Pipeline, if I'm unable to pump fuel, well, that could definitely cause a problem as far as production goal interdependencies. There is also the idea of maintaining quality of the product. Cybersecurity risks that can adversely affect the quality of a given product. There are some studies that indicate you don't have to destroy something like a centrifuge. All you have to do is make it work a little less efficiently. So what we're trying to do is to protect against compromise of the integrity of the manufacturing process. And finally, this is very much in line with not only the CUI protection objectives of 800-171 controls, but with many of the privacy laws. We need to maintain sensitive information that might either lead to the loss or compromise of the organization's intellectual property and sensitive business data, which might include personally identifiable information. So as you can see here, we're taking the identify category, and you can see from this illustration the controls and the subcategories that apply to maintaining human safety, maintaining environmental safety, maintaining the quality of the product, maintaining production goals, and maintaining trade secrets. For the protect category, you see the controls that are listed for access control, awareness and training, data security, information protection processes and procedures that support human safety, environmental safety, maintaining quality of products, maintaining production goals, and maintaining trade secrets. For the detect category, you have anomalies and events, security continuous monitoring, and detection processes whose controls also support maintaining human safety, environmental safety, the quality of the product, production goals, and trade secrets. For the respond category, you have response planning, communication, analysis, mitigation, and improvements, which also illustrate the mappings that can be applied to human safety, environmental safety, the quality of the product, production goals, and the maintenance of trade secrets. For recovery, you have the categories of recovery planning, improvement, and communication, which also align to the mission and business objectives of maintaining human safety, maintaining environmental safety, quality of product, production goals, and the maintenance of trade secrets. There's a very important aspect towards the select that goes into the selection of controls. And that is referred to as the categorization process, where we essentially look at the impact if something happens. Now, the way that the controls are listed, they're basically put into three categorizations, categories, where if the potential impact is low, the loss of confidentiality, integrity, and availability could be expected to have a limited adverse effect on the manufacturing operations, manufactured product, assets, brand image, finances, personnel, the general public, or the environment. If the potential impact is moderate, the loss of integrity, availability, and confidentiality could have a serious adverse effect on manufacturing operations, manufactured product, asset, brand image, finances, personnel, the general public, or the environment. If the potential impact is high, the loss of integrity, availability, or confidentiality could be expected to have a severe or catastrophic adverse effect on the manufacturing process. What we do in this presentation, however, is where there is a potential of a process of a categorization being either low, moderate, or high. We're going to use the high watermark color, which in this case is red, when controls are applicable to multiple impact levels. The next part of this presentation is going to be looking at the individual categories, and what we're going to do is select very specific subcategories. So our first example is that of identity and asset management, which is otherwise known as IDAM. Here, what we're looking at is a manufacturing profile. Whenever you see the term MPG, that is Manufacturing Profile Guidance from the Cybersecurity Framework document. What the control is all about is to enable the organization to achieve business purposes that are identified and maintained consistent with their relative importance to organizational objectives and your risk strategy. So ID-A.AM1 is requiring you to document an inventory of manufacturing system components that reflect a current system. Those components could include PLCs, sensors, actuators, robots, machine tools, firmware, network switches, routers, power supplies, and other networked components. The system component inventory is going to be reviewed and updated as defined by the organization. Now, what you'll notice are the NIST controls that are referenced in the manufacturing profile guidance. Those are CM, Configuration Management 8, and a lot of the control enhancements that go along with configuration management. When we look at ID.AM1, its applicable CUI requirement, it simply states that you're going to establish and maintain baseline configurations and inventories of organizational systems. Notice it doesn't go into the specifics of a manufacturing process. It's very generalized. And it's not that it's wrong that it's generalized. It's just that if you have the manufacturing profile, you're going to better be able to protect your manufacturing environment. The next category in the subcategory is business environment. So with your business environment, you're going to be defining your organization's mission, objectives, stakeholders, and activities so that we can better understand and prioritize them. We're going to take that information and use it to inform cybersecurity roles, responsibilities, and risk management decisions. An example of one of those controls in the business environment class is that the organization's role in the supply chain is identified and communicated. There is no equivalency in the cybersecurity framework subcategories covering CUI for defining the business environment. This is again an example of some of the gaps that exist between the cybersecurity framework profile and NIST Special Publication 800-171. The next example we're going to take a look at is governance. Governance involves creating policies, procedures, and processes to manage and monitor organizations' regulatory, legal, risk, environmental, and operational requirements, and to be able to inform the management of cybersecurity risk. The example that we're chosen is with ID.GV4. We're going to develop a comprehensive strategy to manage risk in manufacturing operations. That's going to include the cybersecurity considerations in the risk management strategy, which we will review and update as necessary. The NIST controls that we're going to use involve program management. Once again, this is an example of something that is not specifically listed in NIST Special Publication 800-171, but is foundational to establishing not only the governance, but the risk management strategy that the organization is going to require, which will enable you to create all of the necessary policies that you would be assessed on. The next identifier is about a risk assessment. And with a risk assessment, you as an organization are going to understand the cybersecurity risk to organizational operations. You are going to be conducting a risk assessment of the manufacturing system, looking at threats, vulnerabilities, likelihoods, and the impact to manufacturing operations, assets, and individuals. You are going to be sharing this information with relevant stakeholders so that you can all make informed decisions about the level of protection required. When you look at the equivalent in NIST Special Publication 800-171 and the CUI requirements, all it's suggesting is that you periodically assess the risk to organizational operations, assets, individuals resulting from the operation of organizational systems and associated processing, storage, and transmission of CUI. I ask you, which is going to better protect your manufacturing environment? At some point, you will need to develop a risk management strategy. It will guide all the decisions you make in terms of how you treat your risk within your organization. The risk management strategy, you're going to establish priorities, understand what your constraints are, establish your risk tolerances, create assumptions that are going to be used to support operational risk decisions. The specific control referenced in the manufacturing profile guidance deals with the idea of the risk management processes being established, managed, and agreed to by organizational stakeholders. There is no equivalency within 800-171. The next one and final one in this category is about supply chain. So once again, especially post-COVID, there is a lot of concern about the level of supply chain risk that exists and the management of that supply chain risk. So what the control is going to suggest that you do is implement a cyber supply chain risk management process that's going to help you identify, assess, communicate, and facilitate addressing the risk-related issues associated with the sharing of sensitive information, be it the use of information technology, operational technology, services, technology-based input products, and non-technology-based input products supporting the manufacturing system. The cyber supply chain risk management process needs to be approved by organizational stakeholders. including those responsible for informational security and operational technology systems. Supply chain is not referenced in 800-171. Next broad category we're going to get into is protect. And the first one we're going to look at in particular is access control. So what I want to point out to you here is, depending on the nature of the environment that you're operating in and what the level of risk associated with your manufacturing system is, the number and amount of controls that you would actually implement will escalate appropriately, as opposed to the one size fits all of the approach within 800-171. Again, this is trying to optimize the amount of money that you and capital that you have to invest in protecting your manufacturing environment. There is an identity and access management control family of controls that would fit into the protecting of identity and access management. Now, there are, regarding the protection of CUI, all types of controls that are referenced, but they are nowhere nearly as focused on the manufacturing system. Awareness and training. One of the things that is always a concern is escalation of privileges, especially to a manufacturing system. So what we're going to do is to ensure that the right people have access to the right pieces of your manufacturing environment at the appropriate time. Principle of least privilege, roles and responsibilities. You can see that some of the CUI requirements for awareness training do cover some aspects, but they're more focused on the technology controls and not necessarily the manufacturing and the protection of manufacturing systems. For data security, if something has a moderate impact, you'd be implementing software, firmware, and information integrity checks to detect unauthorized changes. There are some NIST controls that would be associated with this at moderate levels of impact and at high levels of impact. Once again, there are no specific controls. There are no CUI mappings for this control that is critical to support your manufacturing processes. Another perspective is that you have information process protection, processes and procedures. What you're dealing with here is a personnel security program for the manufacturing system. Personnel security program needs to include policies, position risk designation, personnel screening, terminations and transfers, access agreements, third-party roles and responsibilities, personnel sanctions. And here you're looking at all of the processes that go along with it. There are NIST controls, but again, they don't specifically address a manufacturing environment. They simply cover control unclassified information. For maintenance and the protect category, for low and moderate impact, you are going to enforce approval requirements, remote maintenance. Again, think of all the industrial control systems and their vulnerabilities. Implement strong authenticators, record keeping, session termination for remote maintenance, something especially appropriate for things like pipelines. For a high impact system, you're going to be implementing a diagnostic service pertaining to the remote maintenance that can be performed from a system that implements a security capability comparable to the capability implemented on the manufacturing system. The CUI equivalent simply states require multi-factor authentication to establish non-local maintenance sessions. Again, the lack of specificity is an issue. For protective technology, you are looking at safeguards to restrict the use of portable storage devices, things like USB drives. And when you have a high and moderate impact system, what you're doing is protecting and controlling portable storage devices containing manufacturing system data, either while it is in transit or storage. You are supposed to be scanning all portable storage devices for malicious code before they are used in a manufacturing system. To restate the obvious, the CUI mapping is nowhere near as specific about protecting your manufacturing system. We're now in the detect category. And for anomalies and events, the first thing that we're going to wind up doing is establishing a baseline of network operations and expected data flows for the manufacturing system that we are going to document. There is no equivalency in 800-171 for something that is essential. You need to know what is going on in your network. You need to know the processes that are appearing on your network as well. There is also continuous monitoring that is geared towards a manufacturing system as a control. You're going to be conducting security status monitoring of personnel activity associated with a manufacturing system, enforcing software usage and installation restrictions. There are some equivalencies within the CUI mappings of 800-171, but they don't talk about a manufacturing system. They just talk about CUI in general. So what you might be doing is protecting your CUI, but not necessarily protecting the manufacturing system that might be using the CUI, which might be more vulnerable. Another aspect of the detection processes, where you're going to define roles and responsibilities for detection activities on the manufacturing system so that we can ensure that there is accountability. Once again, you have a situation where you have NIST controls listed, including program management, which is 853R5, but you don't have an equivalent CUI mapping. For response planning, for the manufacturing system, you are going to specifically create cybersecurity event management systems for the manufacturing system so that you can recover that manufacturing system as quickly as possible. The CUI equivalent is simply about tracking, documenting, and reporting incidents to appropriate organizational officials. It doesn't do you any good to track and report to organizational officials and or authorities if you can't recover from the cybersecurity event because you didn't have a plan. Something that I consider to be very important, and you can always tell whether there was a communication strategy by the announcements that are made to the press, but you need to make sure, as far as communications go, that everybody understands what the objectives are, what the restoration priorities are, how and what sequence things will be accomplished, and who are the people responsible for a given event response. The equivalent CUI requirement is to test the organization's incident response capability, not addressing a manufacturing environment. Under respond and analyze, you're going to categorize the cybersecurity incidents according to the level of severity and impact consistent with the response plan. There are CUI requirements, but the CUI requirements 3.6.1, 3.6.2 tend to repeat themselves in this particular area of respond, not specifically addressing a manufacturing environment, but merely the handling of CUI. The mitigation is about containing cybersecurity incidents to minimize the impact on a manufacturing system. All you're doing in the CUI requirements is tracking, documenting, and reporting incidents to the appropriate organizational officials and authorities. In my opinion, it is much more important to minimize the impact on the manufacturing system and to actually have a plan for it. Another part of the respond category are improvements. And what we hope to accomplish here is to incorporate lessons learned from the ongoing incident handling activities into further incident response procedures, training, testing, and implementing the resulting changes accordingly. There is an equivalent as far as CUI goes, but again, there's lack of specificity regarding a manufacturing environment. Recovery planning for a low and moderate impact system would be for you to execute the recovery plan during or after a cybersecurity incident on that manufacturing system, restoring it within a predefined time period from configuration controlled and integrity protected information representing a known operational state of the components. If you can imagine all of the ransomware that has been taking place across the globe, had you had this capability, you could have mitigated that problem rather quickly instead of paying ransomware. If you have a high impact system, the objective is going to be for you to be able to continue essential manufacturing functions and services with little or no loss of operational continuity and sustained continuity until you have a full system restoration. That would be a very, very important fact for your customers to know. The equivalents in the CUI space and 800-171 are, once again, not as specific. It's not that they're bad, it's just that they don't deal with manufacturing. We would like to see improvements if it is a low, moderate, or high impact. You want to incorporate those lessons learned from an ongoing recovery activity into system recovery procedures, training, testing, and implementing resulting changes. There are equivalents, but not geared towards the manufacturing sector. Finally, and this is the last category and the last subcategory, that is communications. It's exceptionally important to have a crisis response strategy. That crisis response strategy could have within it actions to shape attribution of the crisis, change perception of the organization in crisis, and reduce the negative effect generated by the crisis. Now, what's important to note here is that there's no NIST specific control in the manufacturing profile guidance. However, there is COBIT 5 guidance. COBIT is well recognized by the accounting community as an indicator of proper levels of governance. There is no NIST control for this. So what can we say in terms of our conclusion? First, 800-171, NIST special publication 800-171 by itself fails to address many cybersecurity framework profile controls with no mapping at all. The times where there are mappings, they can be subsets of the recommended controls, and they could be rather lacking in thoroughness, and they're certainly not focused in on the manufacturing sector. Important cybersecurity framework categories like business environment, governance, and risk management strategy are omitted in NIST special publication 800-171, which may lead you to potentially designing your controls poorly, which means they may not work when you actually need them. If you use the cybersecurity framework profile for manufacturing, it is the recommended approach for control implementation of 800-171. And the fact that it is so adaptable to future governance and regulatory requirements and compliance requirements would be the primary reason to go with the cybersecurity framework profile instead of simply using 800-171 by itself. I want to thank you for attending this webinar. I hope you enjoy it. If you wish, you can use the contact information below to obtain further information about not only this, but other course offerings from 327 Solutions and Parava Cyber Solutions. Thank you and have a good afternoon.